In this section, we're going to be looking at patterns and inductive reasoning. Inductive reasoning is reasoning based on patterns you observe. So let's look at an example of this. We're going to try and find and use a pattern. So here we have 3, 9, 27, 81. We want to find out what the next two terms in this sequence are going to be. So when we look at 3 and 9, we know that 3 times 3 is 9. And then 9 times 3 is 27. 27 times 3 is 81. So in order to find the next two terms, we have to multiply the last term of the sequence by 3. So 81 times 3 equals 243. And then 243 times 3 equals 729. So we used inductive reasoning in order to figure out the next two terms. So let's look at another example of this. Here we have three different images. We have a circle with a triangle inside, then a circle with a square, then a circle with a pentagon. Each circle contains a polygon that has one more side than the preceding polygon. So a triangle has 3 sides, the square has 4, and then the third image has a pentagon which has 5 sides. So that means the next image is going to have a polygon with 6 sides, so it's going to have a hexagon on the inside. And then after that it's going to be 7, so it's going to be a pentagon. I mean a heptagon. Now we're going to look at another example of using inductive reasoning, except this time we're going to look at a conjecture. A conjecture is a conclusion you reach using inductive reasoning. So we're going to look at some circles, and we're going to try and figure out what conjecture can we make about the number of regions 20 diameters form. So let's say the first circle there has 1 diameter, and 1 diameter forms 2 regions. 2 diameters forms 4 regions. 3 diameters form 6 regions. So we can see that each circle has twice as many regions as diameters. So 20 diameters form 20 times 2, or 40 regions. Now we're going to look at collecting information to make a conjecture. The question is, what conjecture can we make about the sum of the first 30 even numbers? So let's make a column for the number of terms and a column for sum. And we're going to collect some information and then try to make a conjecture based on that. So in the first row we have 1 term, so the first even number, so that would be 2. Two equals 2, which equals 1 times 2. Now we're going to look at number of terms when it's 2, so that would be 2 plus 4, which equals 6, which is also the same as 2 times 3. Now we're going to look at 3 terms, so that would be 2 plus 4 plus 6, which equals 12, which is the same thing as 3 times 4. Now we're going to look at 4 terms, which is 2 plus 4 plus 6 plus 8, which equals 20, which also equals 4 times 5. So we can see that each sum is the product of the number of terms and the number of terms plus 1. So based on that, we can conclude that the sum of the first 30 even numbers is going to be 30, which is the number of terms, times the number of terms plus 1, so 31, which equals 930. Now we're going to look at counterexamples. A counterexample is an example that shows that a conjecture is incorrect. Now we're going to look at an example of finding a counterexample. Here we have the problem. You can connect any 3 points to form a triangle. That is a conjecture, and we want to find a counterexample to this. So first, let's support the conjecture. If we have 3 points, we can indeed form a triangle. But now we're going to look at a counterexample. If we have 3 points, we can connect 3 points in a way that makes it a line. Here we can see that by connecting these 3 dots in a line instead of a triangle makes it a counterexample to the claim. Now we're going to look at another example of this. Here we have, when you multiply a number by 2, the product is greater than the original number. That's the conjecture. And this is true for positive numbers, but false for negative numbers and 0. For example, if we had the number 2 and we did 2 times 4, we would get 8. So that number is indeed greater than the original number. But let's say we did 2 times negative 4. We would get negative 8. And negative 8 is actually less than the original number, so this is a counterexample to the conjecture.